Atomic nuclear physics is going to focus on three things. The first one is decays, the second one is half-lives, and the third one is E equals mc squared. We'll start with decays. There's three types. There's alpha, there's beta, and there's gamma. An alpha particle is a helium nucleus. It is not harmful to you in most cases, but it is helium gas. The beta particle is a highly energetic electron. What we mean by highly energetic, we mean it's very fast. Gamma is light. It's high energy light. It's different than other types of light because it's emitted from the nucleus. If we have uranium-238 and it undergoes an alpha decay, we must put a helium nucleus on the right side of the equation. 238 is 4 plus 234. 92 is 2 plus 90, and the periodic table will tell us that thorium is our resulting element. If instead it underwent a beta decay, 238 is 0 plus 238, 92 is negative 1 plus 93, you'll get neptunium. If you have a gamma decay, gamma is light, it has neither mass nor charge, so you still maintain the exact same atom that you had. Ions are tricky because of the charges. If we have a carbon-14 ion with a +1 charge, that means you lost an electron. You did not gain a proton. If you gained a proton, you would no longer be carbon. Carbon-14 decays into beryllium-10, which leads into the half-life idea. The half-life of carbon-14 is 5,730 years. So if we look at a sample and only 25% of our carbon-14 remains what we originally had, that means if we start with 100, we cut down to a half. At 50, we cut down to a half again. To 25, 2 half-lives have passed by. The bone is 2 times 5,730 years old. If you're given a situation where it says 3 half-lives have gone by, what percent remains? You started with 100%, 1 half-life goes by, you're down to 50. 2 half-lives go by, you're down to 25. A third half-life goes by, you're down to 12.5%. You have 12.5% of the original substance remaining. This can work too with masses. If you have 80 grams and 3 half-lives go by, what do you have left? After 1 half-life, you're down to half of that, 40 grams. 2 half-lives, you're down another half, to 20 grams. Third half-life, you're down to 10 grams. There's 10 grams remaining. Keep in mind it can be tricky, where it says if you started with 60 grams, over time you're down to 20 grams. How many half-lives went by? 20 won't work. We'll use 15. Well, after 1 half-life, I'd be down to 30 grams. After 2 half-lives, I'd be down to 15. 2 half-lives have passed by. A lot of people like to think it's 3 half-lives. They count 1, 2, 3. But it's not 3 half-lives. It's 2 half-lives. You started with 60. This was not the first half-life. This was the 0th half-life. This was the first half-life, and this is the second half-life. The last bit about this is E equals mc squared. So we might have a uranium-239 reaction in which we lost 0.005 kilograms of uranium. It wants to know how much energy is released. E is 0.005. C is 3 times 10 to the 8th squared. A lot of people get confused because they don't know what to put for C. C is the speed of light. This can work too for a hydrogen reaction. If you take a hydrogen, you add another hydrogen, and as a result of doing this over and over and over again, you've lost 0.02 kilograms of mass. Again, E is 0.02 times 3E8 squared. As for how do we detect radiation, we use magnetic fields. If I have a magnetic field with particles being emitted into it, my light particles are uncharged, so the gamma ray will travel through undisturbed. Using the right-hand rule, palm down, index finger points up, the alpha particle is going to bend to the left. The beta particle, I'm going to use my left hand, is going to bend to the right. Note that the beta particle bends more than the alpha particle because the mass of the alpha particle is greater than the mass of the beta particle.